Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 14 problem of this month on LeetCode. Before starting, if you guys haven't subscribed to my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 799, Champagne Tower. So this question is asked in Google as well. So let's read the problem statement. We stack glasses in a pyramid where the first row has one glass, the second row has two glasses, and so on until the 100th row. Each glass holds one cup of champagne. So here something like this. So in first row you are seeing just one glass. In second row you are seeing two glasses. In third row you are seeing three glasses. So if I just give the indexing, so let's say my indexing start from 0. So 0th row, first row, second row. So here I'm just giving the indexing. So here then some champagne is poured into the first glass at the top. So this is the first glass at top, let's say something like this. So you are pouring some champagne into the first glass, is poured into the first glass at the top. When the topmost glass is full, so when this glass is full, this topmost glass is full, when the topmost glass is full, any excess liquid will fall equally to the glass immediately to the left and right of it. So excess water is going to fall to the left, to the right equally. Any excess liquid poured will fall equally to the glass immediately to the left and right of it. Okay. When those glasses becomes full, when these glasses become full, let's say, and then let's say there are more glasses here, something like this. This is one, this is one, and this is one. So when those glasses becomes full, any excess champagne will fall equally to the left and right of those glasses, and so on. So we are pouring the champagne in the top of in this top, and when this is full, then left and right. When both are full, then again to its left, to its right. Same way for this glass also, from its left to its right, like this. So like this process goes on. A glass at the bottom row has its excess champagne fall on the floor. So let's say this is a bottom row. So here if there is any if this glass becomes full, let's say, so champagne will fall to the ground. Glass at the bottom row has its excess champagne fall on the floor. All right. So for example, after 1 cup of champagne is poured, the topmost glass is full. After 2 cups of champagne are poured, so the two glasses on the second row are half full. What it is saying here? So here there are some glasses like this. So it is saying that after 1 cup of champagne is poured, the topmost glass is full because the capacity is just 1 right here. So each glass holds 1 cup of champagne, only 1 cup. So here this is full. After just 1 cup of champagne, this is full. Now after 2 cups of champagne, so one more cup of champagne. So definitely half will go to this side and half will go to this side. So after 2 cups of champagne are poured, the two glasses on the second row are half full. So definitely this will be half full and this will be half full. And after 3 cups of champagne are poured, so one more cup we pour, so half goes here and half goes here. So then this becomes full, this becomes full. So after 3 cups of champagne are poured, those 2 cups becomes full. So there are 3 full glasses total now. So with the 3 champagne cups, 3 glasses are full. So after 4 cups of champagne are poured, so what will happen after 4 cups of champagne? So here again 1, 2, 3, let's say there is one more row. So now one more, so definitely that will go here. Okay, in half and half, in half and half. All right, these are also full. So now this half is nothing but 0.550, you can say this half is nothing but 0.50 only. So then from here 0.50 goes here, and then again from this also it will split to two parts, 0.50, 0.25 and 0.25 goes here. Same way from here also, first one like fourth cup, so half goes here, so this half again will split, so again from 0.25 from here and 0.25 from here. So overall in this you will see 0.25, in this you will see 0.25 coming from here, 0.25 coming from here, so overall 0.50, and here you are seeing total 0.25. So after 4 cups of champagne are poured, the third row has the middle glass half full. So yes, this is half full. And the two outside glasses are a quarter full. That is 1/4. So I hope that this is clear now what is happening in the problem. So very easy problem statement, right? So now after pouring some non-negative integer cups of champagne, return how full the jth glass in the ith row is. Both I and j, it is saying, are 0 indexed, so that is why I'm taking here starting from 0. So what does this line mean? This line simply means that if you have something like this, okay, let's say something like this, and here you have something like this, so you are going to say this is 0th row, this is first row, this is second row, and you are going to say that this is 0th row 0 cup. You are going to say this is first row 0th cup, first row first cup, this is second row starting from 0th cup, second row first cup, second row second cup. That's the simple meaning. So now after pouring some non-negative integer cups of champagne, return how full the jth glass in the ith row. Both I and j are 0 indexed, and these are the some constants given to you. So poured value is from 0 to 10 power 9, and the query glass and query row, these values very small, 0 to 100. Okay, no issues. So now here, so it is saying, if you see just this example one, okay, so it is saying give me the value of first row first glass. That's it, means this glass I'm talking about, first row and query glass 1. So it is a 0 indexed. All right, so first row first glass, right? So we are pouring just 1 cup here, so this is full, there is no water spill goes here and goes here, so 0 only, right? So we poured 1 cup of champagne to the top glass of the tower, which is indexed at 0, 0. There will be no excess liquid, so all the glasses under the top glass will remain empty. That's it. See this example number 2. So we are pouring 2. So again, so we are pouring 2. So we poured 2 cups of champagne to the top glass of the tower, which is indexed at 0, 0. There is 1 cup of excess liquid, right? So glass indexed at 1, 0 and the glass indexed at 1, 1 will share the excess liquid equally, and each will get half of the champagne. So 2 cups na, so one is going to make it full, and then half goes here, half goes to this side. So 0.5 here, 0.50 here. So you have to just return this query row 1 and query glass 1. That's it. All right, so that's it. Here this one you have to return, so 0.500. That's it. Okay, so now I hope that you guys are clear what we need to do. Now let's understand how I'm going to do this. So let's say, let's take some little bit big example. So now everything will get very clear. So let's say you are pouring total 4 glasses, and you have to, let's say, find query row for okay, let's me discuss this query glass value. Okay, let's check all the glasses. Okay, so let's say you have something like this. Let's say you have something like this. This is top, and then this is something here, this is what you have here, then this is what you have here. Let's say this is what you have. Okay, now you are pouring 4 glasses. Okay, in general, first 4 glasses, right? So first cup, so it will make it full. Then second, so for second, half goes here and half goes here, so that simply means 0.50 here, and that simply means 0.50 here. Clear this thing? Now third, so third again split equally, so then this is going to become full, and then this is going to become full. So I hope that this is clear. So now here what will happen, after pouring 3 glasses, so after pouring 3 glasses, all these 3 glasses are full, all these 3 are full. Okay, all these 3 are full now. these are full. Clear this part? Now we are pouring the fourth cup of champagne. So fourth cup of champagne here comes. So no space, so half goes here, half goes here. So that simply means 0.50 goes here, 0.50 goes here. Again no space here, so 0.50 is also going to split. So 0.25 goes here, 0.25 goes here. Same way, same here. 0.50 is going to split again, so 0.25 goes here, 0.25 goes here. Clear this part? So in the end, here you will see 0.25, here you will see 0.50, and here you will see 0.25. I hope that this part is clear. After pouring 4 glasses, this is what will happen. Clear this part? Okay. So now here, if I ask you to just give me the answer of this. So this is 0, 0. Clear? This is nothing but 1, 0. This is nothing but 1, 1. And this is 2 second row, 0th column. 2, 1. This is 2, 2. So here, if I ask you here query row 2 and this one, so that means you are going to return the output of this. Clear this part? 0.50. Clear this part? Okay. So this is the output for this one. Okay. So now here, if you see one thing, query row and query class values. Here, if you see the constraints, so it's in 0 to 100 only, 0 to less than 100. These values. Okay, so overall in total that simply means 100, around 100 we have. Okay, so here also if you see one pattern, let's say if you create one 2D type array, let's say this is 2D array, you can create it any size. Okay, it's your choice. Maybe let's say you create 101 into 101 size 2D array, let's say. Okay, but here I'm just taking the small example, so here I'm not creating big. Okay, let's say I created this one, but you can definitely expand it if you want. Okay, so here if you see this thing now, if I just give the rows, 0th row, first row, second row, third row, 0th column, first column, second column, third column, fourth column. So here at 0 by 0, at 0, 0, what you have at 0, 0. So at 0, 0, you have this value 4. Okay, so in top you are going to fill it with 4 cup of champagnes. This is what you want, right? Initially 4 cup of champagnes. Its capacity is just 1. Capacity of everything is just 1. But I am saying initially you can pour it with 4. So let's say I'm writing 4 here. I'm writing 4 here. Now after that what will happen? After that here if you see for this one, the overall capacity is what? 1 for this one. Okay, so now, but right now if you see the value here, this value is greater than this capacity 1.0, right? So that simply means that there will be overflow from here, right? So how much water will be overflowed from here? Tell me, think about it. How much water will be overflowed from here? So 4 cup of champagne I am pouring, 1 cup of water will get absorbed to this one, right? So only 3 is extra. So this 3 is going to split into half and half like this. Clear? This 3 is going to split in half. So I will say that this is 1, 0. So 1, 0 means I will say here 1.5 goes, and here in this also 1.5 goes. This is what I will say. Clear this part? So 4 is the total, 1 is absorbed, 3 left out, and this 3 is split equally. So half goes here, half goes here, half of 3. Clear this part? This is done. Okay, now, and here if you see, these are indexes, I and j, 0, 0. I and j are 0, 0. So next time, what are the indexes we are filling? Next time here we are filling I plus 1 and same j. and here in this side I am filling I plus 1 and j plus 1. So see, this is what I fill here. Okay, so if this is overflowed, then I filled but these indexes I plus 1 j and I plus 1 j plus 1 with half values. This is 1.5, 1.5. Okay, now next time for this one you are going to check now. This is again greater than 1.0. So definitely there will be overflow, water overflow. So how much extra we have here? Extra that we have here is 0.5, right? This is extra here. So this I will divide it with 2 extra, because half goes here, half goes here. So I will get 0.25, and I will update what I plus 1 j, that simply means this cell with 0.25, and I plus 1 j plus 1, that simply means this one with 0.25. That's what I'm doing. Clear this part? Okay, same way for this one. Now you are here for this one, again you are going to split it two halves. So 1.5 extra is 0.5, 0.5 divided by 2, you are going to get 0.25. So 0.25 comes here. So overall this is going to become 0.50 now. This one 0.25 from this one and 0.25 from this one, overall 0.50, and here it is going to become 0.25. Clear this part? This is done. This is done. Okay, so now here if I ask you to return me the output of query row 2, right? So query row 2 is getting filled if you just execute this, then this and this. You don't need to execute this now, because query row is 2. So if I just execute until here na, so from here only I can get the champagne, extra champagne to these classes of row 2. So after that I don't need to execute. I can stop the process. So at 2 1, what is the output? What is the value I have stored? That is what you need to return, 0.50. That's it. That's it. So this 2D array, actually 2D array is nothing but a DP approach I'm doing. Okay, I didn't say it intentionally in the starting that this is a DP approach. I'm going to tell you the code of this, how you are going to write the code. Very simple, same thing, whatever I have written here, same thing you will do. So here if you see query class and here query row value is from 0 to less than 100. So in total we are storing approximate 100 value. So let's say I will take here max value, let's say 101. 101 into 101 I will create for safe site. So here I will say private static final int max is equal to 101, and here you have to take dp double, dp is equal to new double, and here you will just say max, and now top glass. So here you have to build the tower row by row. So in the top class initially dp of 0 comma 0 value is going to be this pod value, and now you have to build the tower row by row. So here you have to write for int row is equal to 0, row is less than query row, and here row plus plus, and here for int, so col is going to start from 0 only, and here if you notice the column value, so column value is always less than equal to row. So here see this is column, so it is this value is always less than equal to this. So 1 comma 1, 2 comma 2, we are never seeing 2 comma 3 where our column value is greater than row. We are never seeing that. So here I will say col value is always less than equal to row, until here only I need to run, and here col plus plus. So now here if current glass overflows, then in that case you have to write something like this: if dp of row and column, if this value is greater than 1.0, so that simply means overflow. So how much water is overflowed? So you have to write like this: double overflow is equal to the value which you have at this particular position. So just copy this, paste it here, and subtract 1.0, because this glass of champagne is getting absorbed in that same glass, and the rest we will split in half, and then we move it this half to the this overflow water to the left side and the right side. So how you are going to update the left side? So your left side, I told you here, it is going to be I plus 1 j, or it is going to be I plus 1, right side is going to be I plus 1 j plus 1. So here I will simply say, dp of row plus 1, that is nothing but I plus 1 j, and second thing here right side means I plus 1 and j plus 1. So that's what I'm doing here. And in this, what you need to do, you have to add the overflow water. So this is the overflow water, so you have to add it here, you have to add it here, semicolon, semicolon here, and you can say this is nothing but your left child, this is nothing but your right child, and that's it, that's it. And here you have to simply return math dot min of 1 comma 0, and then you have to return here dp at this, you have to return this now query row, and here you have to return the query glass. That's it. Declare this here. Now let's run it, and here you have to change it to query. Let's run it again, and here query row, r is capital, no, like this now, query row. What is the query row I'm taking here? This is the query row, right? So just copy this, paste it here. Now let's run it. So see, all the test cases have been passed. Now let's submit it. So see, our solution is empty, right? This is your first approach. Now we'll move to the second approach. So you are pouring again 4 glasses. So you know. Now, if I ask you, tell me how the water is getting filled in this glass. So now it is very easy for you. You guys are going to say that water is going to come from this side and water is going to come from this side. This is what you are going to answer me, right? So same way, if I ask you here how water is getting poured to this glass, so you are going to say that this water is going to come from here. Same way, if I ask you how water is getting poured to this, or champagne, why I'm saying water, champagne, so champagne is going to come from here. This is what you're going to answer. And here, same way, if I write the indexing again, so 0th row, 0th column, first row, 0th column, first row, first column, second row, 0th column, second row, first column, second row, second column. Now in this glass, if you see first, in this glass, so water is coming from, let's say these are my indexing I and j, which are nothing but right now it is 2 comma 1. So water is coming from this, I can say this is nothing but left parent, and left parent I can say it is nothing but I minus 1 if you see, and j minus 1. Am I correct? So if I is 2, so I minus 1 is 1. If j is 1, j minus 1 is 0. So 1 comma 0, yeah, it is correct. And water is coming from this side, and I can say this is nothing but your I minus 1 and j only. If I is 2, so I minus 1 is 1. If j is 1 and j again 1, so yeah, this is correct, 1 comma 1. So from here this is clear that in this I'm getting the champagne from here and from here. But is this always true? Is this case always true that I will always get the champagne from left parent and right parent? No, it is not possible here. It is not possible here in this part. Here I'm getting the champagne from here, but I'm not getting any champagne from here this side. I'm not getting. All right. So here definitely we have to add one step, one check here, that I can say if here if you see 1 comma 1 and this is going to be 1 comma 2 now. If I get the water from here, that simply means it is 1 comma 2, 1 comma 0, 1 comma 1, 1 comma 2, right? But here if you see, I told you initially itself that your column value, it should not be greater than row. So I will add one case here, that if your column value is greater than the row, just return 0.0. That means you are not getting anything from here. Same way, if you see this, in this side also you are not getting anything from here. You are not getting anything from here, this side. And here if I just, it is 1 comma 0, so I can write it like this, 1 comma 1 minus 1. No, no, this is not good, right? My column value, it should not be negative. My index can't be negative. So here column is less than 0, so I will just add this condition. Simple. If column is less than 0 or my column value is greater than row, just simply return 0.0. That simply means answer is not possible. Clear this thing, right? Okay. So these are the few basic things that I need to check. Same way here, I am getting some water, but that water is going to come from here. Okay, so let's take this only. So in this, water is coming from here, same way in these two, the water is going to come from here and from here. Okay, from here I have started and I reach to this end. From here I see that water champagne is coming from here, and then in these two, champagne is coming from this, and here champagne is coming from top only, right? So this is the one base case. This is also one base case. So in my base case I will say that if my row is equal to 0 and I'm using and symbol, and call is equal to 0, so both are equal to 0, then from here in this I will just simply return the total poured champagne, total the champagne that I poured in this, right? So this is what I'm returning, total champagne poured in this, right? So from here I return the total champagne, which is, let's say, 4 in our example. So now I need to give to the left parent, okay, here some champagne goes, here some champagne goes, but how much? So that is going to be the overflow from the parent. So overflow from the left and overflow from the right. So here I told you this is nothing but 4 minus 1, because 1 is absorbed in this. Then we have to divide it with what? 2. So that nothing but 3 divided 2, that is nothing but 1.5. So 1.5 is going to come here and 1.5 is going to come here. Then 1.5 and 1.5. So again here if you see, overflow again will happen. 1 is absorbed, so 1.5 minus 1, so 0.5 is the extra, divided by 2, so 0.25 is going to go here and 0.25 is going to go here, like this, and this is going to be 0.50. This is what you are doing, right? This is what you are doing. And here, okay, this is simple, all right? So here if I just write a few base cases, okay, whatever I've told you. So let's say this is your method, right? So in this method, let's say from here you are going to return the math dot min, max, how much champagne a glass can hold, max. So max it can hold 1.0 only, right? And what is the min it can hold? Min it can hold maybe 0, nothing, maybe up to 1, not more than 1. So here I'm just taking the min. So let's say here I have one method, get amount, named method, let's say, and here in this I'm just going to pass this pod, I'm going to pass this query row. I need the answer of this, so I just ask this method get amount to give me the amount. That's it. Now I have to explain how this method is going to work. So here I will say what? So here I will say first, okay, first this same thing you have to write like in previous code. So private static final int max is equal to 101. But right now let's not use it. I'm not going to use memoization as of now. I will simply write the code without memoization, and let's see what will happen. So here I will say private double and this get amount, and in this get amount I will pass all this stuff, int pod, int row, let's say, and int column, you can say, right? So generally I'm passing like this, something like this. So now here what will happen? So invalid position, I told you what are the invalid positions. Invalid position, so if your column value is less than 0 or if your column value is greater than row, so in that case this is invalid position, so you can simply return 0.0 here. And one more base case, that if it is a top glass, so in that you have to just simply write like this, if row is equal to 0 and column is equal to 0, in that case you have to return the poured champagne in this. That's it. And here the values, I told you that champagne is coming from the left and right parent classes. Champagne coming from left and right parent classes. So how you are going to fill those? So here again you are going to call this double left parent. So double left parent. So here again you are going to write this method, same method. So let's copy this, get amount pod, and here actually we are passing this row, right, for simplicity now. So let's change it to row, and this is nothing but a column. And here, okay, this is in query row, it is query glass now, this thing I think I changed it. So query glass. So this is what you have to write, query glass. Here if you see now, this is query underscore class, correct, right? Okay, so this is done. So now left parent. So left parent, if you see here, I told you coming from here and here. So this I and j, so I j is filled with I minus 1, j minus 1. So here I will say row minus 1, and here I will say column minus 1. And here if you see from this side, so row minus 1 and j is the same. So here I will again, this is for left parent, same way you have to write it for the right parent. So here you have to say right parent, and here get amount board, and here row minus 1, and here just simply column. That's it. So these are the sampling coming from the left and the right. So now I'm just like this is just calling this method and this method. I'm not worried now how it is working, because it is also going to work like it's the same, that how it's working. So now my total dependency is on this. So this is going to give me the amount that is coming from the left parent and right parent. Okay, but these left parent and right parent are also going to absorb, right, some champagne. So overflow we have to calculate actually in reality. So calculate the overflow from the parents. So here what you have to write, so you can simply say double overflow from left. Okay, now here one interesting thing, tell me here so you have something like this. Okay, so you have, let's say, one glass you poured here, and then you are giving equally to the left and right side. Okay, now here if I apply this formula, okay, and let's suppose somehow I get some negative value. Okay, I get some negative value in this. So in this, how, what is the formula actually you are applying here? You are applying what formula? So whatever the value you have in total, that is going to be absorbed in this. So let's say 4, so 1 is absorbed, right? 1 is absorbed, and then you are going to do half of this. This is what you are doing. So 3 divided by 2, then you are going to get 1.5. Okay, but somehow here, let's suppose you get some value smaller than this one. Okay, you do something like that. Okay, so in that case you may give the negative answer. So I don't want you to return the negative answer here. So that is the reason what I will do here. I will say math dot max of 0.0, and here the left parent minus 1.0, and here I divide it with 2.0. So from here I will take the max of this. So it should be more than 0.0, only then I am taking. So there may be some cases now where from one of the classes I may get extra value. From this side my value is coming as positive, but from this side maybe value is coming as negative. So in that case also, let's say in this there is just 0.75 water, but can you send the same water to here, because your code is calling this also. So in that case what you will do, something like this, minus 1 divided by 2. So in this case you get negative value. No, in that case we don't need to fetch anything from here. You just say 0.00, that's it. Okay, so that's the reason I'm writing it like this. Same way here, double overflow from the right also you need to check. So here you have to just change it to right, and math.max of 0.0, and here right parent minus 1.0 divided by 2. Okay, and now you have to return what? You have to return the overflow from left and plus overflow from the right. This is what you need to return. Okay, so now let's do one thing. I didn't memorize anything. Let's run the code and see. But if you see this example 3 is very big actually. So I'm getting time limit exceed error, right? So because of this test case, let me delete this test case. Now let me run it to see if our code is working fine for example 1 and 2. So yeah, code is working fine for example 1 and 2, right? So that simply means we need to do the memoization now. So again, now this will take place. This will help us, this max. So again, size is if you see query row, query column, size is 100. So here I will take max is equal to 101, and here I will just create the memo to the array. So that is also very simple. Private double memo, and here you have to write new double max and max. And here one more thing, here I'm taking the min of this. So in generally, why in reality actually why I'm writing this, because if you have some glasses like this now, and let's say you pour 1,000 champagnes here, so if I just want to return the answer of this, so definitely you will get some bigger value, because from here you didn't send, your recursion didn't send the check, send the water to below glasses, because there are no glasses. It is going to actually spill the water, but your recursion process ends here from by fetching the champagne from here, and it ends here. So instead of that, I will just take the minimum value. So minimum value should not cross 1, because after that the definitely water will go to the land only. So that's the reason, main reason why I'm writing this. Okay, all right, now let's implement this memoization. It's very simple memoization. So here this is memo, and I have created this 2D array memo, and here in this main class, so here I will just initialize the memo table with -1 computed uncomputed state, right? So that's what we do while implementing this memoization. Same code. Int I is equal to 0, I is less than max, I plus plus, and here for int j is equal to 0, j is less than max, and here j plus plus, and here memo of I and j value, I'm just going to set it to minus of 1.0. So this is just uncomputed state. As of now, all the values are this. So once I calculate any value of memo of I and j, right? Any value of memo of I and j. So here I will say this. Okay, so this I will say simply I will store the output of this to this, and here I am taking as row, and this I'm taking as column. So whatever the value of this overflow, right? So I can simply do one thing, and I can simply take it, Control C, and I paste it here, and here I will simply return this. You can also write it like this. So in memo I store this value, and I'm returning this. And once in the starting itself, I will just simply check one base condition. If I know the value of this, if memo of row column, okay, if this value, I will say if it is not equal to -1, that simply means I have computed it -1. So in that case, I will simply return what? I will simply return memo of this row column. Okay, now let's run it. So see, both the test cases has been passed. Now let's submit it and see. So see, our solution is happy, right? Now here, let me show you a few things. Let me do one thing here. Instead of this, if I just simply return this thing, right? So now see what will happen. Let's see here. All test cases have been accepted. Now let's submit it. So see, it is saying that in this example, if you see, it is saying that in one glass I'm holding this 135, 83347, this much water, right? So this is not good. So that is the reason that I want to restrict it, because excess water, I want to send it to the ground. So I have to take this, right? So this is clear now. This is clear, right? One change. Now here, one more thing. Why I'm taking here this like this? Why I'm taking it like this? I can simply write it like this as well now. Here let me just comment it. Here I can simply write it like this. I can remove this, and I can remove this. This we need to remove. Let's run it again. So see, now here also I'm getting negative output. Negative. It is saying that I'm getting the negative amount of water in a glass. This is not true now. This should not be true, right? So that is why here I have to take the max. So in a glass, minimum is 0.0 and max is this one. So that's what. So here let me just remove this, and here this is not required. That's it. Okay, so this is your overall code now. So now let's submit it one more time finally. So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in the comment section. Till then, keep coding and keep practicing. Meet you in the next video. Thank you. Bye bye.